All right, welcome to the Unit 3 retake review. We're going to go through some test hints on Unit 3. I'm going to start with number 1, so you might want to have your test up as I go through it and talk about it. You can go ahead and pause, do your number 1, and then come back and start working on number 2 when I move into number 2. So just kind of use this as you're going through that way. So first question asks which sum is rational. So some steps to determine whether or not we have rational numbers. There's two ways. If you add two rational numbers together, you're going to get a rational answer. Okay, that's what this is right here. Rational plus a rational gives you another rational. Or if you add two irrationals together, sometimes you can get a rational answer when you do that. So you're just going to have to kind of check each of these to determine which one is rational. A little reminder, a rational number is something that can be made up by dividing two integers. So examples, any integer that, like 25 over 5 would give me 5, okay? Or you could write it as a decimal, 5.0. If it's terminating, if the decimal has an end to it, any fraction is rational, and then all perfect squares are also rational. Repeating decimal, so something like 1 over 3 is a rational number as well because it was written as two integers, dividing two integers. Okay, now an irrational number is something that cannot be made by dividing two integers. So never ending decimals, any non-perfect square. And then the number pi is another good example of an irrational number because that decimal continues forever. It's non-terminating. So you need to go in and just check each of these. So if you add the square root of 25 plus 1.75, do you get a rational number, something that has a terminating decimal? Or do you have something that is irrational that continues forever and ever? So go ahead and test each of these to determine which one is going to give you that rational answer. I'm going to go ahead and move on to number 2, which product is irrational. So we're going to do something very similar to what we did in number 1. You can get an irrational product two ways. Remember, product is talking about multiplying. When we multiply a rational and an irrational number together, so a rational times an irrational is always going to give me an irrational number. Or sometimes when we multiply two irrationals together, we still get an irrational number. Again, you're just going to have to check each of these. One of these answers is going to be irrational. So the one that has a never-ending decimal, that's going to be your irrational answer. The other three, they're going to end up being perfect squares since these are all square roots. So if it's a perfect square, you're going to get an actual integer as an answer. Those are not irrational. They are rational numbers. The one that gives you the decimal parts, that's going to be your irrational answer. All right, so go ahead and pause number 2, find your answer, and then come join me on number 3. So number 3, it says to look at the expression 2 square root of 8 times the square root of 20. And we want to know which of these is equivalent to the expression. So the steps here. The first step is to multiply the numbers outside the radicals together. So like the 2 is outside. And then here I would really just have a 1 out front. So I'd multiply those two parts together. Okay, and then I would have to multiply the numbers that are inside, okay, so the same idea, but the ones that are inside the square root together. And then we're going to simplify that radical. So you're going to get an answer, okay, something that might look, you'll have some number times the square root of some number, and then you are going to have to break down that square root. Just like we did here with the square root of 20, we broke it down. We picked factors of 20, 4 and 5 were factors. 4 has factors of 2 and 2. 5 was a prime number, so there are no other factors of 5. We took out that group of 2s that came out of the house because they had their buddy to get him out of the big house. But the 5 was left behind because he didn't have any friends, so he got stuck in the house. You're going to do that same process. After you multiply the numbers out front together, that number is going to go here. I'll kind of color code it for you. Okay, and then the number inside is going to be those numbers on the inside multiplied together, and then you need to break it down. Okay, so once you finish up number 3, you can join me with number 4. Here we want to simplify. It says you can only add radicals that have the same number underneath. So if I look underneath, I've got 45 and then I have 3 and 3. So these two are like terms. So we can go ahead and add those together. Now, the next step says that we need to simplify the first radical as much as we can. So this guy out here is all alone, but that square root of 45, I'm going to try to break that down. So just like in the last example when we kind of talked about the big house and bringing out the pairs, you're going to do the same thing with that part. Okay, you're going to break down that 45. Just remember at the end, after you break that all down, you still have that -2 out front. Okay, so you're going to need to multiply that by whatever you take out, whatever pairs you have, and then you'll put in whatever you have left behind. And then you just need to fill in whatever you think 3 square root of 3 plus 2 square root of 3 is. Okay, this part right here, that's going to be at the end of my answer here. We're just going to fill in that piece there. Okay, number 5, what are the zeros of the function represented by the quadratic expression? Okay, so steps. You can either use the quadratic formula to solve, or you can plug in the choices for x to see which ones give an answer of 0. So if you're not super confident with the quadratic formula, this would probably be the better option. You literally take the -1, plug it in for x. If that, when I plug in -1, if that gives me 0, then -1 would work. But then I'd have to test, does 2/3 work? So I'd plug in 2/3 for x and see if that whole answer gave me 0. If it did, that would be my solution. If it didn't, you'd check the next one. So you could check -2/3 and x equals 1. Now, those of you who would rather just go ahead and try the quadratic formula to solve, here is our quadratic formula down here. Okay, that's our formula. -b plus or minus the square root of b squared minus 4ac all over 2a. You would plug in your pieces to find your answer. This is just an example of the quadratic formula. I'm not going to go through it with you because that's what you're being tested on, but you could identify your a, your b, and your c from your quadratic function here. So you'd plug those pieces into your formula right here to find your two answers. Okay, so we're going to move on to number 6. Again, if you need to pause at any time to go work on your test, feel free to do so. We're going to work on the next one here. So it asks, what are the solutions to the quadratic equation? So 4b squared minus 49 equals -9. And we want to enter your answer with no spaces, just like you see here. So when you write this, you'll have x equals one number, comma, another number, okay? No spaces. So the first thing is you want to get the equation in standard form. So everything needs to be on the left side and this side needs to be set equal to 0. I have a -9. To move -9 to the other side, we have to undo it or do the opposite operation or the inverse. So I would add 9 to both sides, okay? I'm going to give you guys this first step. Okay, so when those cancel, I'm left with 0. That's what we're trying to do to get it in standard form. Okay, so then from here, we would just simplify to get our quadratic function to go ahead to use the quadratic formula with. So 4b squared doesn't have any other like terms, can't simplify that, but -45 plus 9, that's going to leave me with -36. Now I have an equation and I can use the quadratic formula to solve. So again, you need to find your a, you need to find your b, and you need to find your c. Remember, just in case you need, ax squared plus bx plus c. This is your standard form right here. So when you're matching up your parts, I didn't talk about this on the last one, but this might help just in case you need that. The number out front of your x squared is your a term. The number with the x is the b term. And the number by itself, that's your constant, that's your c term. And don't forget to use your signs. So notice how in the example here, we have a -8 and a -48. So when I take out my b and my c, they're both negative. And again, if you need to kind of see the steps here, we've got it all written out for you so you can see the process of the quadratic formula. Right, number 7, find the discriminant. So the discriminant is the expression that appears under the square root or the radical sign in the quadratic formula. So right here, this part in green, that's the discriminant. That's the only thing we have to do or calculate. So when I'm given 6q squared plus 8q minus 3 equals 0, it's already in standard form. You need to find your a, your b, and your c, okay, from your equation, and you're going to plug it into just this part, b squared minus 4ac. So whatever your a, b, and c are, plug those values in. That answer is what you're going to type in right here. If it's negative, put the negative in there as well. You just have to type the number in. All right, pause if you need to, finish up number 7, and we're going to move on to number 8. So how many solutions does the following quadratic function have? We have negative 8x squared plus 2x minus 7 all equals 0. If you'll remember, the discriminant is what tells us how many solutions we have. So the first step is to find the discriminant, just like we did in the last example. So I have to do A, B, and C. First, I have to find A, B, and C from my equation. And once I gather that, I'm going to plug that into my formula right here, which is just the b squared minus 4ac. When you get that answer, if it's a positive number, you have 2 solutions. Okay, if it was a perfect square, so let's say you got a number like 25, for example. If you got 25, that's a perfect square, you'd have 2 rational answers. And if it's not a perfect square, so let's say we had something like 31, it's still a positive number, okay? That's 2 irrational numbers. If you get an answer of 0, that means we have 1 solution. And if you got a negative answer, let's say I got negative 18, that means I have no real solution. So these are just example answers to kind of show you what to look for each of these scenarios, but you're going to use your A, B, and C from your equation, plug it into the discriminant, and then determine what type of solution you have. Okay, number 9, what's the vertex of the graph? So a vertex is an ordered pair. Okay, when we're talking about a parabola, remember a parabola is our U-shaped graph. This guy is positive out front, which means I'm going to open upward, and that means that my vertex is going to be down here. It's going to be that minimum value. So to do this, to find our parabola, we use this formula here, not to find the parabola, but to find the vertex of the parabola. We start off by finding our x, okay, is negative b over 2a. That's our first step. Find negative b over 2a. So again, I need my a and my b and my c from my function. So you have to tell me what's my a, what's my b, what's my c, okay? Once you find that answer, once you find x, you're going to take that answer and you're going to plug it back into your function. So hypothetically speaking, let's say you get 1 for x. You would take that 1, where'd my pen go there? We'd take that 1, we'd plug it in for x, get your answer for y, and that would be your solution here. So x comma y, that's how you type it in. There's my x. So my y, plug x into x squared plus 10x minus 9. So whatever answer you get here, you're literally plugging it in for x here, and that will give you your answer for y. You're finding a coordinate. Number 10, does the function f of x equals negative 4 times x plus 4 times x minus 3 have a maximum or a minimum? Okay, so this is in vertex form, this function here. It has subtraction sign in the parentheses. This is actually not in vertex form. This is in factored form. But the key here is the number out front, okay, this a term, tells us if we're opening up or down, okay? So if A is less than 0, the graph opens down and has a minimum. Okay, so this number out front here, I misspoke just a second ago, so I'm going to kind of redo here. So the number out front, A, if it's less than 0, the graph opens down and it has a maximum. I think I said minimum the first time, but I just kind of want to show you what that would look like if we're talking about. Come on, here we go. Okay, so if I open down, there's my maximum. That's the height of my graph. Whereas if I open up, I'm going to have a minimum or a bottom value. So you're looking at that number out front. If it's less than 0, it opens down and has a maximum. If it's greater than 0, it opens up and has a minimum. So you're just going to tell me that number out front, is it less than 0 or greater than 0, and then read through each of those scenarios to determine which choice you should pick. Okay, number 11, graph the following function. So f of x equals -2 times x plus 3 all squared minus 1. Okay, so this is in vertex form. Remember that it has a subtraction sign in the parentheses. This means that we move in the opposite direction. We want to look at the value of a in the function. Okay, the reason we look at a first is because this tells us if we open up or down. I have a -2. Okay, if we go back to that last slide, if I have a -2, okay, less than 0, opens down, it has a maximum. So I can look here at the graphs to see which one of those is a maximum. Okay, the next thing we want to do is look at the value of h. This is the axis of symmetry, the line that cuts it in half. Remember that your h is opposite. If you're in my class, I talk about how Hank lies and Kelly tells the truth. So Hank is lying. Okay, so this is a positive in the vertex form, but that really means we're moving in the opposite direction. Okay, so you want to look for your axis of symmetry. Remember, that's that vertical line that cuts your parabola in half. Okay, and it's opposite of this sign. So you're looking for the graph that has an a value of -2. So does that mean we open up or down? And then my value of h is opposite of this. So you can look for that that invisible line, that axis of symmetry that's going to go through that value, that x value, okay? All right, number 12, what is the average rate of change of the quadratic function from x equals -3 to x equals 2? So my steps, I need to evaluate my function at x equals -3. This literally means I take my function and I plug in 3 wherever I see an x. Okay, and you're going to find that answer. Then I'm going to do the same thing and I'm going to find the answer when I plug in 2. I'm plugging in 2 wherever I see an x and I'm going to get that answer. This is going to give me my y1, this is going to give me my y2. This is my x1, this is my x2. You're going to plug those values into your slope formula and that is going to give you your answer for your average rate of change. All right, that is the end of our test review. Hopefully that intro to each of those kind of helps set up each problem for you as you're working on the retake.